Hello, welcome to chapter 2 of the ergonomics book. Chapter 1 was just about the book, so there was nothing in there we need to look at. So here we are on chapter 2, and it's going to be about the basics of ergonomics. And we are going to get started right on now. All right, here we go. Let me get this full screen. Henry Ford stated, okay, we are getting ahead of ourselves. Go back to the beginning there. Now, let's first of all, what is ergonomics? Coined by that guy, a Polish biologist, 1857. That was even before my time. Two Greek words, ergon meaning work, and nomos meaning principles or laws. So it's simply put, it's fitting the workplace to the worker, not make the worker adapt to the workplace, although sometimes that has to be done, of course, but fitting the workplace to the worker. And the board of certification for professional ergonomists says it's a body of knowledge about human abilities, human limitations, and human characteristics that are relevant to design. Ergonomic design is the application of this body of knowledge to the design of tools, machines, systems, tasks, jobs, and environments for safety, comfortable, and effective human use. Okay, that all makes a little bit of sense, doesn't it? I kind of like this thing. This is says the machine and the task, design, machine, and human factors. And when they all come together, the machine and the human match, and the task and the match and to the human, it's matched to the machine. Well, that's perfect ergonomics. They all come together in the middle of that little diagram. Anyhow, how did it start? Well, there's evidence back in the 5th century, BC Greeks used ergonomic principles. Hippocrates described how a surgeon's workplace should be designed and how the tools would be arranged. He also suggested to physicians that they inquire as to one's profession during examination. In the 19th century, Frederick Winslow Taylor pioneered the scientific management method, which proposed a way to find the optimum method of carrying out a given task by maximizing human performance. For example, he found that by reducing the size and weight of coal in ore shovels, the amount of coal or ore being shoveled could be tripled. And in the early 1900s, Frank and Lillian Gilbreth developed time and motion study. This is like the fathers and parents of time study. I've done some time studies, and they're pretty interesting. They reduced the number of motions in bricklaying from 18 to 4.5, allowing bricklayers to increase their productivity from 120 to 350 bricks per hour. This elimination of repetitive motions and extended reaching are methods of controlling work-related musculoskeletal disorders due to cumulative exposure to the same muscle group. Henry Ford stated, the work must be brought to the man waist high. No worker must ever have to stoop to attach a wheel, a bolt, a screw, or anything else to the moving chassis. Of course, Henry Ford was famous for his assembly lines. And he also was way ahead of his time. In 1914, he started paying his workers $5 for an 8-hour day. $5 for an 8-hour day, can you imagine that? As opposed to $2.34 for a 9-hour day, which was the norm at the time. So some things in safety are objective, which means provable and measurable. For existence, the height of railings and mid-rails, ratings of ladders, height before fall protection is required, and that's different in general industry and construction, as you know. But some things in safety are subjective, which means it relies on assumptions, beliefs, opinions, and could be influenced by emotion and personal feelings. A lot of ergonomics is subjective. It depends on fatigue, pain, and other ways a person feels. It's real, but it depends on how they feel. So one person could do one job and feel one way, same person could do that same job and feel a different way. This is neither positive nor negative, it's just a fact. And dealing with employees is an excellent way for safety professionals to gain information and respect. Ergonomics seeks to prevent work-related musculoskeletal disorders, WMSDs, you're going to see that term a lot, by applying principles to identify, evaluate, and control physical workplace risk hazards. So we're going to have some hazards, and we need to control those hazards. And you know about controls. We're going to talk about them again. Musculoskeletal disorders are a class of disorders involving damage to muscles, tendons, ligaments, peripheral nerves, joints, cartilage, including the spine, vertebral discs, bones, and or supporting blood vessels. WMSDs are not typically due to acute events, but occur slowly over time due to repeated wear and tear or microtraumas to the tissue. For example, dental hygienists from repeated gripping of small diameter tools while they're getting inside your mouth and giving you pain while cleaning your teeth, okay, while applying force. Microtrauma, this is an important word here. Microtrauma is a small, minor, limited area tissue damage or tear. Cumulative trauma occurs when rest or overnight sleep fails to completely heal the microtrauma, and the residual trauma carries over to the next day. Damage continues to proliferate if the exposure or dose remains unchanged. So in other words, you keep making a lot of microtrauma, and you don't have time for that microtrauma to completely heal. Some of that's going to carry over and it's going to build up. WMSDs are also known as a couple of other different names here and initials. Cumulative trauma disorders, or CTDs, repetitive strain injuries, RSIs, repetitive motion trauma, RMT, occupational overuse system. I don't know why there's no acronym for that one, but there is. Examples of work-related musculoskeletal diseases include epicondylitis, which is sometimes called tennis elbow, tendinitis, Dacre-Vane's disease, which is tenosynovitis of the thumb, trigger finger, and it's got into the guns, Raynaud syndrome, vibration white finger, carpal tunnel syndrome, we've all heard of that, I'm sure, back strain, and I'm sure we've all heard of that, and probably some of us have had it. OSHA uses the term MSD for musculoskeletal disorder and defines it as a disorder of the muscles, nerves, tendons, ligaments, joints, cartilage, or spinal discs that was not caused by a slip, trip, fall, motor vehicle accident, or similar accident. So they're defining it kind of by what it's not, which sometimes that's the way it has to be. Did you know that there's enough human bones in the entire human body to make up an entire human skeleton? How about that? Standing neutral position. This is just a kind of a basics here. When somebody's in a neutral position, means they're not those stresses on their body they get from an awkward position. So fingers are gently curved. In other words, if you just hold your hand down by your side and just let it hang there, your fingers are kind of gently curved. They're not straight. Yellow and straight, that's not natural. So the wrist is in line with the forearm. It's either bent up, down, or in or out. Extension. Now they're talking about usually the standing neutral posture sometimes has your arm out in front of you as if you're holding something in front of you. Forearm rests with the thumb up. It is not rotating to make the palm face down or up. So you have your hands in front of you, your elbow at 90 degrees, and your thumb sticking up. That's your natural position, or neutral posture. Elbow is in neutral posture when the angle between the forearm and upper arm is close to a right angle, 90 degrees. Some extension up to 110 may be desirable, but it's around 90 degrees, your elbow. On the upper arm, though, from the shoulder to the elbow, hangs straight down. It doesn't stick out to the side, abduction, or pulled across in front of the body like adduction, or raised to the front, flexion, or raised to the back, extension. Shoulders on a resting position, neither hunched up or pulled down and not pulled forward or back. The head is balanced on the spinal column. It's not tilted forward, back, or to either side, just natural, neutral. Back, the spine assumes its natural S-shaped curve. The upper spine, the thoracic region, is bent gently out. That's like why your shoulder blades are. The lower spine, the lumbar region, is bent gently in. The spine is not rotated or twisted to the left or right, and it is not bent to the left or right. So there's some of your neutral postures on the left. And then the other ones show awkward postures, back flenching, back extension. That stuff gets in the way up there a little bit. Oops. All right. And then twisting them and that lateral bend, that's what they're talking about in this thing. Natural posture for work performed in standing position. There he goes. You can draw a line right down there from your up to your body. But you stand with your feet shoulder width apart, knees are flexed, and they're not locked. They're not bent, but they're not locked. Their heads upright, shoulders are relaxed, not forward or backward, chest up, back straight as your normal back gets. Elbows not locked or flexed more than 110 degrees. Wrists are straight. Ears, shoulders, hips, knees, and ankles should be in a straight alignment to maintain the natural S-curve of the spine. Again, that's your neutral standing posture. Again, if your arm's out, then the left picture shows it being 90 degrees, and then on the right two pictures show elbow flexion and elbow extension. Those are not neutral postures, they're awkward postures. Awkward posture, you're going to hear a lot about that in ergonomics. Again, natural posture of the elbow is is on the left, and then the shoulder flexion and extension shown there on the right, and abduction and extension and abduction on the left. So there's some postures of your shoulder and arm that are awkward postures. And that just shows you a picture of a tool. The top tool is when you have as you're doing some drilling that's horizontal, then the tool has to have somewhere around a line. You got to go from that, the way your natural wrist is, to the tool. And so the first grip does not allow you to do that. The second grip, the pistol grip, lets your wrist stay straight while the tool is in whatever is drilling in a horizontal position. Now, if you have something that's vertical drilling on it, now that's the time for the tool in the top photo. You can hold it like that and still have your wrist on the bottom picture, still have your wrist straight. But you can see in the next to the bottom picture, with that pistol grip tool, it doesn't work for doing a vertical drilling. And that's just a basic example of some things in ergonomics there, some principles. So there are some workplace risk factors we're going to talk about. And numero uno on the hit parade is awkward postures. Static postures are almost as bad. Awkward postures mean it's just not what we just talked about in the normal posture. It's awkward. And usually when you see somebody working an awkward posture, you can pick it out just by looking at it pretty quickly. Static postures, a little harder to see because static postures, everybody's going to maintain a static posture for a few seconds at a time. But if you're there in a static posture for a long time, then it becomes a problem. A static posture for a few seconds, even an awkward posture for a few seconds, isn't a problem. But static posture is basically not moving at all. Repetition, doing the same thing over and over again. Force, how much effort does it take to do this job? That's a factor too. Compression, is there compression against any part of the body? That could be a problem too. Single point vibration, usually that comes from a tool. Whole body vibration, and that's usually when you're in a vehicle like a truck or something, a boat or a crane or something like that, where your whole body's vibrating. Duration and magnitude, how long does this activity last, and what's the magnitude of whatever it is? It could be the force, the vibration, compression. Temperature extremes, hot or cold, either one of those could be a workplace risk factor. Inadequate recovery, we talked about micro traumas. Well, those micro traumas, you have to have time to recover before the next time you start doing micro traumas again, or then you have to let your body get back to normal. If you do that, you'll save yourself a lot of grief, but inadequate recovery is a problem. So awkward postures are basically postures outside of the neutral posture. They can stretch the body's physical limits. They can compress nerves and irritate tendons, are often significant contributors to MSDs because they increase the work and the muscle force required. So when you're in an awkward posture doing something, it's even harder for you to do than if you were in a neutral posture. The greater deviation from neutral posture to the higher stress on the body and resultant risk of injury. Examples of awkward postures are raising hands above the head, or elbows above the shoulders, even. They're common in manufacturing and in manual material handling. Kneeling or squatting, they're common in maintenance operations. Sitting with feet unsupported, it can cause blood to pool in the feet and flatten the natural curve of the lumbar spine. That's common among laboratory technicians who work at high benches. Working with back, neck, or wrist bent, for example, when using a microscope. Oops, see that? Well, you can see right there, that video tells you that awkward posture bending over. See what that does to the guy? Static postures, holding a posture for an extended period of time. Examples, gripping tools that can't be put down. You're doing this for hours at a time. Holding arms out or up to perform tasks. Standing in one place for prolonged periods. All of those are static postures. And they prevent blood flow and increase load or force on muscles and tendons, contributing to fatigue. Repetition, same motion or group of motions is performed over and over again. Repetition itself is usually not a problem. What occurs with other risk factors that magnifies the exposure. In the chicken business, in a debone plant where the carcass is coming down, the cone line, where the carcass is put on a cone-shaped object. It comes down it's not really an assembly line, it's a disassembly line because they're taking the chicken apart, not putting it together. And part of the task that the chicken tender is not part of the breast meat. It's a piece of muscle inside the cavity of the chicken. And the only way to get it out is to reach in there and pull it out with your thumb and finger. And it's very difficult. And people doing that have a lot of stress on those fingers. And a lot of times they actually lose their fingernails because they're doing that over and over again. And they're doing it over and over again all day long. Force, the amount of physical effort required to finish a task or motion. Required force increases when other risk factors are involved. So in other words, you have other risk factors increase the amount of force that you need to do the job. More force equal quicker muscle fatigue. And force may also result in muscle strain or damage. The power zone for lifting with the greatest strength, endurance, and control and lower risk of injuries, holding the load close to the body between the knuckle and shoulder height. That's your power zone for lifting. That makes a lot of sense. Drop your hands at your side. That's your knuckle. And then your shoulders. In between there is the best place to lift something. And that's the place where we naturally try to lift something. Compression or contact stress is a concentrated force on a small surface area of the body. Contact stress can reduce blood flow or cause irritation due to the constant pressure. One of the most common sources is a sharp desk edge. Nerves in the forearm are close to the skin surface. Compression of the forearm impedes nerve conduction. Vibration, there's two types, single point and whole body. Single point exposure to a single body parts, such as upper extremity. That's common with tool use. Whole body exposure to vibration throughout the whole body. And that's frequently, like I said before, from vehicles. More on vibration in a later chapter. Duration and magnitude, the time period in which an action continues or lasts is the duration of it. And continuous exposure may not allow sufficient recovery time for muscles, tendons, and nerves. Duration and magnitude or intensity magnifies the risk factors. The magnitude is going to intensity. It magnifies what risk factors are already there. Temperature extremes, cold, greater aerobic demand on the worker, which means they fatigue faster. Reduces dexterity, causing one to grip harder or apply more muscle force. More problematic when present with vibration because both factors constrict blood vessels. So cold and vibration, you got a double whammy there for constricting your blood vessels. That's not good. Heat, workers move more slowly when hot, so simpler tasks can take longer, thus increasing the duration of the exposure to temperature extremes and other risk factors. Personal protective equipment can decrease evaporation from the skin, thus reducing the body's ability to cool itself, adding to the thermal gain. Inadequate recovery. This is a big factor in ergonomics. Muscles need time to rest, to reoxygenate, and remove the waste product of muscle metabolism. There are many ways to rest a muscle group: stretching it, alternating tasks, micro breaks, which are just brief pauses. And probably without even thinking about it, we've probably all done this from time to time in whatever it is that we're doing, whatever task we're performing. Stretched a little bit, did something else for a while, take a little break. Now, personal risk factors. We're talking here about workplace risk factors, and now we're talking about personal risk factors. These contribute to things too. Age, because the repair process takes longer. Don't tell me that, I know. Gender. Certain work-related musculoskeletal disorders are more prevalent in women. Hobbies, knitting, crocheting, and computer gaming. Those hobbies, you're using your hands a lot. And so if you're on your job, you're doing the same thing, and that can make it on the job, the risk factor way more prevalent because you're doing it at home too. Previous injuries, so at risk for re-injury. Smoking. Smokers tend to heal more slowly due to reduced oxygen in the bloodstream. Fatigue causes a reduction in performance and a buildup of lactic acid in the working muscle. Obesity and pregnancy linked to increase in carpal tunnel syndrome. Obesity impacts our lack of flexibility, fluid buildup, and increased pressure on the discs. Medications, they can cause dehydration, swelling, decreased or increased metabolic rates, and a change in electrolyte levels. Physical conditions, poor fitness, when combined with body weight above ideal, can be a prime cause of weariness and fatigue. Painful aching joints and muscles are signs and symptoms now of work-related musculoskeletal disorders. If your muscles are sore and joints are aching, that could be a sign. Pain Tingling or numbness is a sign. Shooting or stabbing pain, again, pain. Swelling or inflammation, even without pain, can be a sign. Warmth or burning sensations. Sometimes you feel that in a muscle or a joint. Stiffness or difficulty moving. Pain during the night. Loss of strength and mobility. These are signs and symptoms. Oh, you're having some problem or may have a work-related musculoskeletal disorder. Again, ergonomics is fitting the work to the worker. So workplace risk factors, forces, heavy, frequent, or awkward. Postures, awkward and static. Like I said, awkward posture. You walk through a plant and you start looking for stuff like that, and you will see awkward postures more than likely. Duration, repetition, vibration, single point or whole body. Compression. Personal risk factors are age, gender, hobbies, previous injuries, physical or medical conditions, smoking, fatigue. Understanding and applying ergonomic principles in the workplace will reduce the physical stress on the body and eliminate potentially serious, disabling, work-related musculoskeletal disorders through matching jobs, task, and work environment to the worker. Other benefits include improved comfort, morale, job satisfaction, and worker health, and improved productivity and reduced worker compensation costs and employee turnover. Those are all good things for the company. And I have stressed this many, many times, and I'll continue to do so. As a safety professional, talk to your employees. They know more about what's going on with their job than their supervisor does. And you can learn a lot from them. And also, when you start helping them, not only will it help your position in the company, help the company, and they'll tell their coworkers, and it'll be good for everybody. So that's it for this, and we'll see you next time.